Hello and welcome. This video is the start of a series of fun little projects I'll be putting together based around the Raspberry Pi. For this project, I'll be putting together a Raspberry Pi with an environmental sensor board along with an LCD screen. The aim is to have the values that the sensor collects show up on the LCD screen and in the console on the monitor. I will be demonstrating two LCD screen options, one being a 16 column by 2 rows and another with 20 columns by 4 rows. I'm thinking that this project will be split up over 2 to 3 videos, with this part covering the initial getting it working part. The second will look at tidying up the code and adding login to the program. The last part will include setting up a database to store the readings and adding a basic web server to show the last 10 readings and an option to download all the readings to a CSV file. With that said, let's move on and take a look at the hardware and software I'll be using for this project. For this particular project, I used the following hardware. A Raspberry Pi 3B 1GB. You can use either a Pi 4 or a Pi 5 if you wish. A 128GB SanDisk micro SD card. It doesn't matter about the size or the vendor, but I would recommend a card of at least 64GB. Power supply for the Pi. An Adafruit BME 280 sensor, which collects the temperature, humidity and pressure. An LCD screen. For this project, I'll be demonstrating the use of a 16 by 2 and a 20 by 4 LCD screen, each of which has a PCF 8574 expander board attached, a breadboard, and a collection of wires. There's going to be roughly around 10 male to female jumpered / DuPont wires. The colors I used were 2 red, which indicate 5-volt power, a single orange cable for 3.3 volt power, 3 black for ground, 2 yellow for I2C SDA or data, 2 blue for I2C SCL or clock, and lastly 1 stemmer QT/QWIC JST SH 4-pin to 4-pin male jumper / DuPont cable. I've included some links in the video description for some of the products I used. In terms of software, for this particular project, I'll be using the Raspberry Pi Imager tool, Raspberry Pi OS Lite, which will be installed on the micro SD card. If you've not used this before, it's pretty much a lighter version of Raspberry Pi OS that doesn't have a desktop environment. A terminal emulator. For myself, I'll be using iTerm 2 on a Mac, but you can use whatever you want given whatever operating system you're on. Visual Studio Code, and for reference, the version of Python used was Python 3.11. Before getting started, I've put together a wiring diagram that shows roughly where the wires are going to go. To save a little bit of time, I've pre-installed the wires into the breadboard and they just need to now be attached to the devices. Starting with the Pi, first install a micro SD card. I have imaged this using the Pi Imager tool to install Pi OS Lite onto the card. After that, install the red 5-volt cable into GPIO pin 2. Followed by the black ground cable next to it into GPIO pin 6. Once that is done, take the 3.3 volt orange cable and plug it into the GPIO pin 1, followed by the black ground cable into GPIO pin 9. That's all the power connections done. Next, install the blue cable on the right into the GPIO pin 3, followed by the yellow cable on the right into GPIO pin 5. Put the Pi to one side for the moment. Moving on to the sensor board, plug the QT stemmer cable into the right hand side of the board. After that, plug the red cable into the column with the orange cable and then the black cable next to that. Then put the blue cable next to the other 2 blue cables and then the yellow cable next to the other yellow cables. And that's the sensor board wired up. Moving lastly onto the LCD screen, rotate it to the back so that the pins are on the right, plug the black cable into the top pin, followed by the red 5-volt cable below that. Then blue cable that's remaining needs to go below the red cable. And finally, the yellow cable just goes below the blue cable. And that's all the hardware wired up. I'll plug the power adapter into the Pi and move on to the next step. With the hardware all set up, the first thing I'm going to do is check for any updates for Pi OS. As this is a new install, there will likely be some to install. I've already got a terminal open and I'm going to SSH into the Pi by running the SSH command with my username and IP address of the Pi. I'm just going to clear the screen. Now that I'm logged in, I'm going to run sudo apt update to update the list of repositories. Next, I'm going to run sudo apt upgrade -y to install the updates. This might take a while, so I'll come back when they've all installed. With all the updates installed, some additional packages also need to be installed. I'll install them using sudo apt install i2c-tools virtual env python 3-virtual env-y. To go over what the packages are, the first one is I2C tools, which is a collection of tools that are used for interacting with the I2C interface that the sensor and LCD screen are connected to. The last two, virtual env and python-virtual env, allow for easy creation of virtual environments for Python. I did have an issue using another method, so I opted to use the virtual env option instead. After those packages have been installed, reboot the Pi using sudo reboot. This isn't always necessary, but I prefer to do it, especially with a fresh Pi OS install. The system will end your SSH session and restart the Pi. Wait for a minute or two and then run SSH again. Now that Pi OS has been updated, the next step is to check to make sure the sensor module and LCD screen have both been detected on the I2C interface. First, the I2C interface on the Raspberry Pi needs to be enabled, as by default it's disabled on Pi OS. To enable it, we simply run sudo raspi-config. Next, go down to Interface Options, press Enter, down to I2C or I2C, press left arrow to go to Yes, press Enter, that's that done. OK to that, and then tab over to finish. Next, we're going to run the I2C detect command to see if the board and the LCD screen have been detected. To do that, we just simply run I2C detect -y1. As we can see, there's two numbers showing, 27 and 77. 27 is the I2C address for the LCD screen, and 77 is the I2C address for the sensor board, which you can check by looking at the back of the sensor board as it's printed on there. This indicates that both devices have been detected and we're good to go. If one or both of these numbers don't appear, double check the cabling and that the I2C interface is enabled. Now that the sensor and LCD screen are working, it's time to start putting together the code. First off, if you haven't already, download and install VS Code for your operating system. Next, click on Open a Remote Window using the icon in the very bottom left of the status bar in VS Code. If you don't see it, check that the Remote Development extension is installed. Next, it will ask you how to connect. Select Connect to Host, then select New SSH Host. Now enter your username, followed by @ and then the IP address of the machine. It'll ask you for the configuration file to update. I usually just select the top one. It'll now confirm that the host has been added. Just click Connect. A new window typically appears, and then you just put the password in for the account on that machine. At this point, it will download and install VS Code Server on the Raspberry Pi, and it will also indicate in the bottom left-hand corner that it's open in remote, and we can see that that's now done. When it switches to SSH and then the IP address in the bottom left-hand corner, that indicates that it's taken care of and we're done. The next thing I would recommend doing is installing the Python extension for VS Code. To do that, just go over to the Extensions tab on the right-hand side in my case, and your side it might be left. And then I'm just going to type Python, and I want the top one, which is from Microsoft, and I want to install it into the SSH session. So I'm just going to click on that. This might take a while, so I'll come back when it's done. As we can see, that's now installed, so I'm just going to close that. Next, open a new terminal in VS Code, unless there's already one present, which in my case there is. What you need to do is create a new folder using mkdir, and I'm going to call that folder project. And then I'm going to cd into that project folder, and it should be empty because it's a new folder. At this point, click on the Explorer icon, and then click on Open Folder. Select Project from the list, and then click OK. Next, we need to create a Python virtual environment, which we will do using virtualenv-p/user/bin/python3, which is the interpreter we're going to use. And the name of the virtual environment is just going to be called venv. Now that the virtual environment's been created, we just need to activate it, which we just need to run the source command with the path of our virtual environment. So in this case, it's venv, and then bin and activate. And we can see that that's now been activated by it saying venv at the beginning of the command line. The last thing we need to do is install some Python packages into our virtual environment. And to do that, we're going to use the pip3 install command with the packages. So the packages we need to install are adafruit-circuitpython-bme280. That package is used to interact with the sensor board. Then we've got rplcd, which is used to interact with the LCD screen, and smbus2, which, if I recall correctly, is a dependency for rplcd. Now that the packages are installed, it's now time to move on to writing the code. First, I'm going to create a file called main.py in the project folder. Once I've done this, this file will automatically open. Now that the file's open, I just want to quickly check in the bottom right-hand corner that this is showing as the correct Python interpreter. If yours isn't selected, just go and find the one that just says venv in parentheses, and then just select it. Usually shows as recommended anyway. Now that that's done, I'm just going to paste in some boilerplate comments that I've made, just to give us an idea as to what I'm actually going to be doing. So the first part is I need to import the required libraries and modules for this project to work. So I'm going to start off with importing the library that's required to make the sensor board work. And to do that, I use from adafruit_bme280 import basic BME280. Next, I'm going to import from date and time. I want just the date and time class. Give that a shortcut as DT. Next, I'm going to import the library for working with the LCD screen, and that will be from rplcd.i2c import char lcd. And then lastly, I want to import board, which again is used for setting up the sensor board. And that's all the imports that we need to do. Next, I'm going to work on getting the sensor board working. There's a couple of parts to this. So The first one I'm going to do is a try block to initialize the I2C interface using board. So I'm just going to call that I2C equals board dot I2C in uppercase, parentheses to initialize. And then there's a couple of exceptions I want to catch. So the first one is OS error. Just call that error. And I want it to raise an exception when that occurs. So raise exception, and then f string, just say critical, and then curly brackets, and then we just put error in. Now I'm just going to copy that exception because I need to just do one more. Paste that in, and I'm going to change that from OS error to value error. The only reason I'm doing these two is because these are the two most common ones that pop up. If any others show up, then okay, fair enough, we can just add them to the list. Next, I'm going to initialize the sensor, and it's very similar to the previous one. So what I'm going to do is just copy the previous one, and I'm just going to make some changes. So the first one is we'll make a variable called BME280, and that will use Adafruit underscore BME280 dot Adafruit underscore BME280 underscore I2C brackets or parentheses rather I2C. So it takes that board parameter or that board variable we created earlier, and these two are exactly the same, so I don't need to make any changes there. The next step is to sort out the sea level pressure, which is also used to work out the altitude of where you are. The number I'm going to put in is just a sample one that I got from Adafruit, but there is a site that you can use, which I've linked in the description below, which actually shows you where to get the actual sea level pressure for where you are to give a much more accurate representation of what your altitude is. So for this part, I'm just going to do BME 280 C underscore level underscore pressure equals 1013.25. So at the moment, that's all the code that's needed to get the sensor board initialized. I did wonder why there was an error. My mistake, Mr. Comma. Next up, I'm going to get the screen initialized. And again, this is going to be another try block. I'm going to just copy and paste this one in because there's not really much point in typing this out. So I'll just explain it once it's all in. So in short, I'm just initializing the LCD screen here. And I'm just passing a number of arguments over to char LCD, which tell it what the expander is. The expander is the module that's attached to the back of the screen to allow for easy interaction with I2C, and PCF8574 is the chipset that's on that expander. Address, that's the I2C address for that particular board. In this case it's 27, but it has to be shown in a byte notation. Port number 1, that's the I2C interface. Columns and rows, columns is the number of characters on a row, and the number of rows is 2, so we can do 16 columns per row, and we've got 2 rows to play with, and we've got a dot size of 8. In terms of the exceptions, the two that I usually get are OS error and not implemented error. OS error just basically indicates that the board couldn't be detected, so just go and check your interfaces are turned on for I2C, and also that your board's wired up correctly. Not implemented error basically implies if I used a different chipset which wasn't supported by char LCD, then it would chuck this error up, at which point you just need to go and check to make sure you're using the right thing. So if the manufacturer says use a different library, go and use that library instead of this one. Now I'm going to switch over to actually putting some output onto the console and the display. This part isn't totally necessary to make this work, but I'm going to do it anyway. So I just created a variable called update output. I'll just set that to true. And what I'm now going to do is create a while loop, say while update output is true, do the following. the first thing I want to do is set up 4 variables. In this case, first one's going to be called temperature, and that's going to be BME 280 dot temperature. And create another one called humidity, and that will be BME 280 dot no, it didn't. It's relative underscore humidity. Pressure equals BME 280 dot pressure. And lastly, altitude equals BME 280 dot altitude. Let's start with some output to the console. I'm just going to do a few print lines. So the first one is, I just want to show the date and time. So I'm not looking for anything too fancy with this. So just do dt.now, and I want it in a particular format. So I'm just going to do str format or str, and format I want is %d, so that's the day. I want %m, that's the month, and %y in uppercase for the year. So that'll give me the full year instead of just a short form version of it. And then give me the time as well, why not? So %h, %m, and then %s, and then /n to give me a new line. So I get a day, month, year format with hours, minutes, seconds shown as well. So next I'm just going to show up the 4 readings, one for temperature, humidity, pressure, and altitude. So just do print temperature first, temperature %0.2f. So I just want it to 2 decimal places, Option Shift 8 to get the degree symbol, and then C, and we do percentage and then temperature. And I'm just going to paste in the other 3 just to save a little bit of time, because they're all pretty much the same format. So we've got humidity, 2 decimal places. We're going to show a percentage sign at the end of that. And then pressure, again to 2 decimal places. And then altitude in meters to 2 decimal places. So that's what I'll output to the console window down here. So what I'm now going to do is sort out the LCD screen. And to start with, what I want to do is use lcd.clear. That will just basically clear the contents of the LCD screen. So if there's anything on there already, that'll disappear. And then I'm going to do lcd.write_string. So this is used to actually put some text onto the screen. And I'm going to do another f string. Now I'm going to have to do shorthand for temperature. So I'm just going to do temp. And again, we're going to go %0.2f. Now I need to do something a little different this time around. So CHR223 curly braces, and then C. So char223 is the ASCII code for the degree symbol. Because the LCD screens use ASCII rather than Unicode or UTF, we have to do it slightly different. I'm going to do /R and then /N. So I'll take it down to the next line and do a carriage return, because these LCD screens work a little different to how we normally work with console output. Then do percentage temperature. And now I need to do one more for humidity. So that'll be lcd.write_string and then f string. And then we do humi %0.2f. Should probably get away with just doing that. And then %humidity. So there's one more import I need to do, and that is from time import sleep. Go back down to the bottom, and I'm going to put sleep parentheses 3. What this while loop will do is take a measurement for temperature, humidity, pressure, and altitude, print it to the screen, and then print it to the LCD screen as well. That's the reason I did 4 variables at the top, is because if I just put them in these print blocks individually, so I could have done something like BME 280.temperature. The problem with doing that is the value here then would potentially be different to the value that gets printed out onto the LCD screen. So if I do it before both have actually been done, before both actually print out, then it's consistent. So I'm just going to save that. And now I'm going to check, see if there's any problems. None reported. Switch to terminal. I'll just make that a little bit bigger. What I'm going to do next is anywhere in the blank space in the main.py file, just right click and then go down to run Python in terminal. I've missed something, haven't I? Oh, There we go. My mistake. That wants to be as. Okay, let's try that again. So right click, run Python file in terminal. I've spelt something wrong. Where are we? BME relative yeah, I missed a D off. Relative humidity. Okay, let's try again. Third time lucky. I'll just push up on my keyboard this time and then press enter to rerun it. There we go. As you can see, we've got it printing out to the console, and if you look in the bottom right hand corner, you can see we've got it printing out to the actual LCD screen as well. Now, because this program's in a while loop, it's never going to stop. So to stop it, just make sure you've clicked inside the console window down here, press and hold Control, and then just press C, and that will just end the app. So that concludes getting this working with a 16:2 screen. Next, I'm just going to give a quick demonstration of getting it working with a 20:4 and what code changes need to be made. I've changed over the LCD screen, and I'm just going to run I2C detect to make sure it's been picked up. There we go. Both are still showing, so that's good. So the only changes that really need to be made in the code is the columns need to be changed from 16 to 20 on our LCD variable, and the rows need to be changed from 2 to 4. And then what we can do is just add a little bit more detail for what we're outputting to the screen. So I'm just going to copy and paste in a few extra lines just to save some time. I am going to delete this one. I'm just going to repaste that back in. This time we've got 4 lines of output instead of just 2. I've kept the text to just 4 letters for each one, just in the interest of consistency between the 16:2 and the 20:4. But otherwise, it's pretty much as you're seeing here. No real difference apart from we just get 4 lines instead of 2. So I'm just going to run this file again. And as you can see, we've got output on the screen and we've got output on the LCD screen as well. And again, just to stop the application, just do Control C and that will stop it. And that's the end of our code. That completes this part of the project. In the next part, I'm going to split up the code into modules for the LCD screen and the sensor, along with adding some logging to help store any errors that are encountered along the way. I will also be adding some environment variables to the program to make it more configurable. For example, including a file that indicates if an LCD screen is connected, and if so, what type it is. For example, is it a 16:2 or is it a 20:4 screen? Thanks for watching. If you liked the video, please like and subscribe, and I'll see you in the next video.